Now see everyone, we understood about big O again omega theta, but so we will going to show I will going to show you what is this exactly. Big O is nothing but, and what is this omega is nothing but, again what is that, theta. Okay, first one I will take big O. See here everyone, observe here please. So I will take big O here, big O. So big O notation, what is this basically? Big O notation is nothing but, you can see it is Z. Big O notation is like this, less than or equal to. So this is what exactly. So we know that. Yes or not? Now I will going to take a few things. You please observe here. Okay. N cube. Understand here everyone. Please understand. N cube. Okay. Equal to big O of n square. Okay. Again. N cube equal to big O of n. Okay na. Again n cube equal to big O of n cube. Okay. Again n cube equal to big O of n power 5. Okay. Again one more. N cube equal to big O of let's take n power 1000. Okay. See this. Everybody please observe this. Now in this, I wanted to satisfy big O, nothing but what? Right side must be greater. Yes or not? I wanted to prove right side greater. Now when you see this one, you can able to see in this. Please see this. In this, which is greater? Basically, n cube is greater. Am I able to prove right side is greater? No. That is the reason why we cannot able to prove this one as a big O. Again, here also you can see which one is greater. Left side is greater actually. Here not right side. So that is the reason why here also we cannot able to prove. Okay. Now you see n cube equal to big O of n cube. This is okay. Because one condition satisfies, because less than or equal to. Again you can able to see n cube is equal to big O of n power 5. This is also satisfies because this side is greater. Again n cube is equal to big O of n power 1000. This is also satisfies. Okay. Now please everybody observe here. Okay, please everybody observe here. Okay, in this, what exact we know that already we understood what exactly, but I wanted to give better than something. Okay, what is that exactly? When you hold the value n naught value, okay, less than or equal to, here you can able to see n cube equal to big O of n cube. This one we will call it as this one I'm talking about. Please see, this one we will call it as tight upper bound. Okay, tight upper bound. Upper bound. Okay na, it's a tight upper bound. Again these things you can able to see all these things. Okay, here you can able to see these things, all these things I'm talking about. All these things we will going to call this one as all these things. Okay, n cube, n power 5, n power 1000, all these things we will going to call it as okay upper bounds. Upper bound. But this one, why I am calling this one n cube is equal to n cube. Okay, n power 3. What it says that basically equal to, it says that at this condition it will going to satisfy. That is the reason why it is a tightest one bound. Okay, tight one. Okay, that is the reason why I will going to call this one as tight upper bound. These things you can able to see greater than. Okay, greater, right? Compared to n cube, this is greater. That's why it is not a tight upper bound. Okay, it's a normal one. So that is what exactly I wanted to tell you people. So this, when you say equals, it will become a tight upper bound. From that onwards, all the n values will going to satisfy. But here, n value already satisfied here. That is what. Okay. Again, these values are, we will call it as upper bound. This side, left side, you can able to see this left side. Left side, we will call it as actual one. This one we will call it as actual. Okay, this is, we will call it as actual. Okay, these are all upper bounds. This is a actual one. Now, for example, what I will going to do, I will going to write like this. Okay, So algorithm A, problem A, that is equal to big O of B. Now here, what is the B? You can ask me, what is this B, sir? B is a upper bound here. You can able to see B is a upper bound. Why? Because I'm telling you. So when you say f of n, when you say what is that? F of n is equal to, okay, greater than or is equal to C dot G of n. We know that one. So what we have to prove? What we have to prove here? F of n is equal to big O of G of n. We have to prove it. Yes or not? Okay. So this is what exactly prove it. F of n is nothing but A. Again, big O of G of n is nothing but B. Nothing but it says that clearly B is a upper bound here. B is a upper bound. Okay, B is the upper bound. B is the upper bound. That is what exactly I showed you. These are all upper bounds. And this is tight upper bound. Tightest upper bound. Tight one. Okay, tightest upper bound. This is all left side is a actual one. Actual things. Okay. Here, one thing you can able to see, one more important thing. So might be, it may be a upper bound or it might be a tight or may not be. Okay. So this one, we are not saying that n cube is equal to n cube like that. We are not saying here. Might be or may not be. Please understand. Might be or may not be. Okay. This may tight upper bound or may not be. May not be. Please understand here. May not be tight upper bound. Okay, tight upper bound. So this one, in this, when you see this function, which one is better, sir? Which one we have to take function? F of n is nothing but you consider as a, G of n is nothing but you consider as B. Nothing. In this case, what we have to do, which algorithm we have to take as a best one. So in this case, what we have to do, this one we will going to consider as a better one compared to B. So this is a better algorithm. A is a better algorithm, better algo compared to P. So this is what you need to understand. That is the reason why whenever you will going to take any program, what we will going to do, we will going to analyze what is the time complexity, at what time we will going to satisfy all those things. Okay, what is the bound, all those things we will going to identify. So in that, which program we have to execute, which program we will going to execute faster, all this we have to identify, means we have to use asymptotic notations. Okay, that is the reason why function A, this one you take it as A is equal to big O of B. When you compare this one, you will going to consider A is a better algorithm compared to B. Okay, so that one we have to understand here. Because why? Because we are using constant and we are changing all these things. That is the reason why. This is the reason why. One, what is that? Actual. Basically, it's an actual one. Okay. So here, no need to worry about the confusion. What is this tight bound or upper bound, all those things. Tight bound is nothing but that's what I told you. So I have given one problem saying that n minus 10 is equal to n plus 10. In that you can able to see at that condition 10 it will going to be equal. After that 30 it will going to be something else. Differently it will going to work. For all n values it will going to give you the greater. So that is what you need to understand here. Okay. So this is a small example for big O. Understanding everyone? Guys got it? Guys got it? Please let me know, please. This one, everybody understood or not? Small. Okay, we will see this one. Small O. Small O. Okay. So here, please take some examples here. Small O. What is the notation is nothing but big, sorry, wait. Small O of, I will write like this, please. Less than. Okay, less than, like this. Small O, less than. Okay. Now, same example, I will going to take it. N cube, that is equal to small O of n. Okay. Okay. Thank you, Jitu. Okay, again, n cube, that is equal to small O of n square. Please see this notation, everybody. Please see this. Okay. What it says that not equal to, but it should be greater than always. That is the reason why. Please observe this one. This one is very, very important. Okay, again, that is equal to n cube, small O of n cube. Again, that is equal to small O of n power 4 Again, that is equal to small o of n power 10. Okay, so all this n cube, n cube, n cube, n cube. Okay, getting everyone? Now in this, please observe here, n cube equal to n cube equal to big O, small o of n. Will it satisfy to this small o? Is it satisfies? No. Yes or not? Basically, this side is greater. What it says that, so basically, so when you say f of n is less than, that is what exactly I will going to write here. F of n is, okay, less than c dot g of n. This should be there. Okay, so that is not satisfied. Right side not satisfies. That's why no, this is not a small o. Again here also, this is a greater one. This is also not satisfies. Again come back to here. When you go to big O, here it is satisfying. Yes or not? Here it is satisfying, but here no, it is not satisfying. That's why we cannot take this. Again this one okay. Again this one okay, because you know right side is greater. Okay, these bonds. Okay, these two. Please here, these two we will call it as upper bound. These two we will call it as upper bound. Upper bound, but not tight. But not tight. Understood now? Got it? This one. Chetan understood this one. Everybody understood or not? This one. What I said. Because the reason is we are not having anything like that. What is that? Less than or equal to is not there. Only less than is there. Yes or not? Jitu correct? Yes or not? Only less than is there. Hello?
Yes, sir.
Okay. Only less than is there. That is the reason why it is a upper bound, but not tight. But when you go to the big O, less than or equal to, you will going to get less than or equal to. That time what it says that very clearly. Okay. Here it will says that it is a tight upper bound, but here no. It is not tight upper bound. It is a upper bound, but not tight. This one you have to understand. Okay. Same thing here also. So suppose if you take the problem like this, A small o of B. Okay. So here you can able to see in this, when you take such kind of function here for A and B, in this what we will going to find, basically you will not going to find any tight. Will you going to find any tight here? No tight, nothing, you will going to get it. Not tight at all. Okay. Not tight upper bounds you will going to find. Yes or not? Not tight upper bounds you will going to find. Understanding why? Because I am telling you these things are very, very important. So we have seen already. Okay, less than or equal to, go for O, big O. Again, less than, small o. Again, if you go for greater than or equal to like this, what is that? Omega. Okay, equal to, go for theta. Okay, like that. So please understand. That is the reason why I'm telling all these things. Please observe. Okay, just you observe. Okay, this one, this is called it as small o. Please, you have to go with such kind of notations. Then only you can able to say it is a small o. Okay, na? Let's go one more. Omega. Let's go one more. Omega. Here we will see omega. Very simple. No need to worry. Very simple. Already explained in the class. Simple things. These are all very simple things. Omega notation here. So here also take something like that. N cube, that is equal to, please observe what is that notation we will going to have in the omega. So that is omega. So what is that? Greater than or equal to, nothing but right side we have to prove it. What is that? Smaller. Okay. So omega of n power 5. N power 5. Okay. I am concluding everything. I am concluding. Okay. And that is what I am concluding everything. Omega of n power 4. Okay. N cube, that is equal to omega of n cube. Again n cube, that is equal to omega of n square. I will take n cube, that is equal to omega of n cube, that is equal to omega of 1. So now you only tell me, okay, please tell me, you only, which side is greater in this? Basically, which side is greater? Okay, right side is greater. That is the reason why we cannot take this. Again in this you check which side is greater. Right side is greater. But here you check it. Okay, so there is a condition greater than or equal to, greater than or equal to. This is okay. We can able to take this one for omega. Again, this is also okay. This one is greater here, but this is n square. So n cube is greater. Again, this is also okay. Again, one more. You can able to see this one also okay. Nothing but what? Exactly. You can able to see all these four. Please here, all these four satisfies or not? Omega. All these four what satisfies or not? But when it comes to here, I told you already. This is when it comes to this one. Please observe here. When it comes to this one we will call it as tight lower bond. Lower bond. Okay, it is not upper bond, it is a lower bond. Please understand here. We are calling here lower bond, not upper bond. So these are all actual one. Okay, big gamma we are calling upper bond. Yes or not? When you are proving that omega, what we have to prove? Omega, okay, greater than we have to prove. Sorry, big O greater than we have to prove. Again, come back. Okay, for omega again you have to prove. Okay, so like that. So we have here we are writing tight lower bond. We have to write here again. One more important, smaller or equal. Okay, so basically whatever it may be, we have to call for lower bond. All these things are lower bond only here. There it's a upper bond, lower bond. Okay, fine, everybody okay? Same thing here also. In this, when you come to any algorithm, you take a is equal to omega of okay b. Here all the things we are calling b, we will going to call it as lower bond here, lower bond. And one more important thing is here, it may be a tight lower bond. Yes or not? This one may be a tight lower bond or not tight lower, not lower bond. Okay, so these things you have to understand. Nothing but what it will going to satisfy this condition. That's why it is tight. Rest of the things are normal lower bonds. But when it's go to big O, it is a upper bond here. Here upper bond. These are all upper bond. Okay, na? So this is one we have to understand. Again, one more we will going to see one more. So one more we will see. What is that? Small omega. Small omega. Small. I will going to finish everything. Don't worry. Those examples are more than enough. You can able to understand everything. Okay. Small omega how to write? Small. Again greater. Okay. That's it. So same examples I will going to take it. Okay. N cube that is equal to omega power n power 5. Okay. N cube that is equal to omega n power 4. Okay, n cube that is equal to omega n power 3. Again n cube that is equal to omega n square. Again n cube that is equal to omega n. Now you people tell me which one we have to prove it greater. So we have to prove this one right side greater. Yes or not? We have to prove right side greater. So sorry, left side greater. We have to prove the left side greater. In this you can able to check it. You can able to check it here. So which one is greater in this? Okay, basically here this one is greater, we can take this one. Here also this one is greater, we cannot take this one. This one also greater, we cannot take this. But here see here, observe here, n cube is greater than n square. That is okay. This satisfies small omega. Again this is also okay, this satisfies small omega. Okay, so this indicates very clearly, these two indicates very clearly, these are all not tight lower bonds. Understood everyone? These are all we will call it as not tight lower bonds. Okay, guys, these things are very important, guys. Please be careful because they have mentioned in the textbook, but nobody is telling all these things. So here you can able to see. So which one we have to take in this? Basically, when it's go to big O, we are taking B is better. Yes or not? So in that we are taking, sorry, in that we are taking, when you go to the big O, okay, we are taking A algorithm is better, but here, see here, but here B algorithm is better. Okay, B algo is better. Okay, where when it comes to small omega, when it comes to small omega, this is enough. This is enough for you people. No need to worry. Okay, so some more things we will going to see. Okay, theta. Finally, theta. We will going to see this one, theta. Theta. Okay, theta notation. So basically, what is the notations we will going to use? Theta. So if you satisfy both, what is that? One is big O, another one is omega. If you satisfy both, so you will going to get the theta. So how it would be? We will going to see that one. Same thing. So n cube is equal to big O of n cube. Sorry, n cube. So this one, what is this basically? I told you it is a tight upper bound. Okay. Big O means upper bound. Please understand, everybody. Big O is nothing but it's a upper bound. Upper bound. Okay, it's a upper bound. Okay. What kind of upper bound you will going to get? Big O? Tight upper bound and as well as upper bound. Tight upper bound also you will going to get it here. In this, you will going to get tight upper bound also. Tight upper bound also you will going to get it. Yes or not? I already told you. Tight upper bond as well as it's a upper bond, both the things you will going to get it. Okay, so basically big O is nothing but you will going to get from tight upper bond. Basically we will going to satisfy equals. Yes or not? After that, for all n values it will going to satisfy each and every n values. So that is the reason why it is a upper bond. Okay, so basically it's a upper bond. Why? Because it is a tight upper bond, because equals is there. Yes or not? When you go to the big O, what you will going to get it? Greater than or equal to, it will going to satisfy this. After that, both the conditions satisfy. That's why basically it's a upper bond, so it will become a tight upper bond. Please be careful with this. And see here, and n cube, that is equal to omega n cube. Okay, so here also same thing. Okay, now this is a tight lower bond. Yes or not? What is that? Basically greater than or equal to. So that's why I will going to say that this is tight lower bond. That's what exactly. Because one condition satisfies for equal, again one more satisfies for greater than. After that, all the values will going to satisfy. Basically, it's a lower bond. Yes or not? Basically, it's a lower bond. Okay, it is a lower bond. That is the reason why it will become a tight lower bond. Okay, that one you have to understand very carefully. So that's why both the condition, if both the condition satisfies, means simply we can say that. Please understand here. Simply we can say that. Okay. So what is that? So yeah, all this satisfy. The theta will going to satisfy here. So it will going to satisfy between two people. Theta is possible. Okay, between these two people, theta is possible. So that is the reason why we can say that n cube is equal to theta of n cube. This satisfies. Because these two things are satisfying, na? That is the reason why it will going to satisfy. So these things, okay, one may be a tight upper bond, another may be a tight lower bond. Yes or not? Because this one also we will going to satisfy. What is that? Tight upper bond we will going to satisfy here. To get this one, please understand, to get this one, theta, to get this one may be a tight upper bond, another may be a tight lower bond. So due to this, we can able to satisfy this. That is the reason why we are getting theta. You know already I explained why I have to take less than or equal to, why we have to take greater than or equal to, what we have to prove, again how we will going to prove using constant. All those things I explained. Little more deeper I am going. Why I am calling tight upper bond? Because equals satisfies here. So that condition we will going to call it as a tight one. Okay, tight bond. Okay, so tight upper bond, that is here we will going to satisfy equals. That is the reason why we will going to call here tight lower bond. Please understand this one. Again, simply we can say here one more. Simply we can say algorithm you take A is equal to theta of B. Okay, so here all both are equal. When both are satisfying, big O as well as omega, in this we can maybe may not be. Okay, you will going to find tight lower bond as well as tight upper bond. Here you can able to see both the things. What is that? Tight lower bond as well as tight upper bond. Okay, so this is what exactly all the things related to asymptotic notation. Okay, all the things, whatever the things which are related to asymptotic notations is there, all these things. I think you people are clear with these things. Okay, small example is there. Okay, see here, small example is there. Suppose I will go and now please see here, everybody observe here. You will going to write an algorithm like this A. Okay, so function A. So you are writing a program. Please understand, you are writing a program. You will going to take an algorithm A. Okay, in this you will going to write some statement. X is equal to y plus z. After that, what you will going to do? For okay, I is equal to 1, 2. Okay, n. Okay, na? So here x is equal to x plus z, sorry, y plus z. Again, one more for okay, I is equal to 1 to n square. Okay, so here x is equal to y plus z. So this is the algorithm you people are written. Now you tell me how many times it will going to execute. One time. How many times it will going to execute? N times. How many times it will going to execute? N square times. Yes or not? Now you people tell me what is the time complexity of this. You people tell me what is the time complexity of this. What is the time complexity of this? Hello? Actual one is what? How you will going to find the time complexity? Basically, you will going to find the time complexity like this. 1 plus, or you can take this, n square plus n plus, okay, 1. Yes or not? N square plus n plus 1. Like this you are taking, right? Now you have to prove saying that. What is that? So finally, we will going to get the value. What is the time complexity value? What is the time complexity you will going to get? Which one is greater in this? What is that? Big O of n square. That is the reason why I'm talking about upper bound and lower bound. See, always this is greater. This one is, by using constant, I'm making greater this one. Yes or not? By making constant, I am making this one greater. So that is the reason why it says that very clearly in this function. Okay, in this function, which one is greater? N square. That is the reason why we says that this function time complexity is big O of n square. Understood, everybody? Everybody got the point? Everybody got the point? Guys, Ashwini got the point? Chetan? Hello?
Yes, sir.
Okay. So please understand. So this is the reason why we were writing. This is the reason why we were writing all these time complexity, all those things. Basically, this is the actual one. But finally, we will want to convert that one into time complexity. That's why big O of n square, you will want to get it. So this is what either you can say here, see here, either you can say also. So this is basically actual one, 1 plus n square. I can call this one, what is that? F of n. Okay, I can call this one as f of n, that is equal to, what is that? Less than or equal to c dot g of n. This one is g of n actually. This one, n power square is there, na? This one is g of n. Big O of, big O of g of n. Nothing but what? So all these values, that is equal to 0 power, okay, sorry, big O of n power 10. If I write n power 10 also, it's okay. Yes or not? Because compared to n square, this is greater. Okay, so that is what exactly you have to understand related to this one. Okay, when you write a program, why we are doing asymptotic notations? Because we have to find the time complexity here. That is the one reason we will going to use all these things. With this program, okay, with this program related to all asymptotic notations we completed. So what is that? One is big O, another one is omega, okay, another one is theta, again small o, as well as small omega. All this we completed. Okay, now all these things we completed. So please understand these things. Very, very important things. These things are very, very important. But if you learn, it will be good for you people. Okay. Fine, guys. Hello, everyone. Fine.